When you hear the largest explosion, what comes to your mind? The crackling sound of firecrackers on the 4th of July? Maybe the rumbling sound of lightning? Or the sounds of missiles used in the wars? Nevertheless, the universe is undergoing much more powerful explosions every second, some of which are so far away that we only now observe them billions of years after they first took place. The biggest explosion in the universe since the Big Bang has been discovered by astronomers. If you want to know more, stick to the end, as this is going to be big as Big Bang. Before we get started, don't forget to drop a like and subscribe to the channel if you haven't already. Make sure that the post notifications are turned on so that you never miss a video from us. Cosmologists' best efforts to piece together the universe's 14 billion year history from the tiny portion of existence that is visible now as summarized in the Big Bang theory. The term Big Bang is interpreted differently by different people. Most typically, it shows the arc of the observable cosmos as it has become less dense and cooler after beginning out hot and dense. This summary boils down to the notion that the universe is expanding, a general principle similar to biology's survival of the fittest that few would consider disputable. It is a frequent misconception that the stars in the sky are constant and unchanging, despite the fact that on the scale of human lifetimes, that would seem to be true. In our galaxy, new stars are actually constantly forming while old stars are dying. On a cosmic scale, the death of our star will be quite quiet. Nevertheless, some of the largest stars in the universe, some of which are tens or hundreds of times as massive as the Sun, will perish in a supernova, an unfathomably immense explosion. Scientists have recently discovered the greatest supernova explosion ever observed, and the effects are so significant that you can even see it from Earth. What exactly is that it's causing these stars to react so violently, and what will happen to you when this supernova explosion inevitably occurs is more significant. There are an estimated 200 billion trillion stars in the observable universe, each of which originated as a nebula, a huge cloud of gas and dust. These nebulae can span hundreds of light years and contain millions of suns' worths of mass. Gravity will soon begin to pull the gas atoms into the cloud closer together, creating clumps that have a little more density. These clumps will keep growing like snowballs rolling down a hill as they continue to take mass from the collapsing nebula. The collapse's core heats up and becomes dense enough to start nuclear fusion after a few million years, where the combination of two hydrogen atoms yields helium atoms, which release energy. Every star's and our sun's brightness have been kept using this method for millions of years. Stars like our sun expand to many times their original size and transform into red giants when the hydrogen fuel runs out. The star will eventually fizzle out after the fuel is depleted, but stars with masses of at least 8 times greater than those of the Sun will experience a totally different death. With enough core pressure and heat, these enormous stars can fuse atoms heavier than helium, such as silicon, carbon, neon, oxygen, and then eventually iron. Silicium is fused to form iron atoms, but this reaction no longer produces energy for the star to use. Instead, it becomes an energy sink. The iron in the core starts to compress since it's not actively creating energy quickly. The constant struggle between the inward pull of gravity and the outward push of radiation pressure is won by gravity over time. Due to the sudden compression, the core briefly reaches temperatures that exceed hundreds of billions of degrees. The collapse happens so fast that the top layers of the star cannot keep up with it. When the infalling material eventually collides with the collapsing core, turning the internal explosion into an outward explosion, all of the pressure that has been building up is abruptly released. A powerful shockwave tears through the outer layers of the star, shattering it to pieces. Between the beginning of the core's collapse and the final catastrophic supernova explosion, only a little period of time has elapsed. Supernovae are the most powerful forces in the known cosmos. The word explosion doesn't even begin to describe their incredible strength. A single supernova can shine for months longer than the combined brightness of all the billions of stars in the entire galaxy. In the constellation of Orion, 550 light years away, is the massive red star Betelgeuse. A supernova is predicted to occur within the next few thousand years as the star is nearing the end of its lifespan. Betelgeuse's supernova will shine brightly enough to be observed from even our remote vantage point on Earth during the day and will appear almost as brilliant as the full moon at night. Even still, it's nothing compared to a supernova explosion that was just found in outer space. The most powerful explosion ever recorded in the history of the universe is confirmed by astronomers. How much do we know about this enormous eruption? Hundreds of millions of years ago, the biggest explosion ever recorded in the history of the universe tore through a plasma cloud, producing the most powerful explosion observed by scientists since the Big Bang, according to a new study. A supermassive black hole, or SMBH, in the Ophiuchus galaxy cluster, located about 390 million light-years from Earth, was the focal point of an eruption that produced powerful jets that tore a hole in the plasma cloud, encircling the galactic cluster that was 15 times the size of the Milky Way galaxy. Near the center of every large galaxy is a supermassive black hole. While huge eruptions have been observed before around these mysterious objects, none have been as big as the one recently discovered in the new study. The previous record holder for the greatest explosion in the universe, a comparable event in the galaxy cluster MS 0735+74, was outperformed by this one 5 times over. According to Chandra X-ray Observatory officials, this lesser event would have needed the SMBH to burn 300 solar masses of material over a period of 100 million years. But even those astounding numbers pale in comparison to the eruption at the core of this latest investigation. Because of their powerful gravitational fields, black holes are best known for pulling matter towards their centers. These strange objects have the ability to divert matter that is falling towards them into strong jets that shoot out into space, far beyond the area where the black hole is located. The vast size of the gaseous crater led astronomers to use X-ray telescopes to rule out the possibility the feature was the consequence of an explosion. Astronomers discovered that the artifact in radio waves they were observing was, in fact, the result of an explosion of unimaginable proportions using the Chandra X-ray Observatory of NASA, the XMM Newton from the European Space Agency, the Giant Meter Wave Radio Telescope, GMRT in India, and the Murchison Wide Field Array, or the MWA, in Western Australia. A majority of solar systems nearby would avoid direct damage from such an event unless they were in the path of one of the potent jets created during an explosion, despite the fact that big eruptions in galaxies can unleash enormous quantities of energy. After the gas supplying the SMBH in the heart of the explosions has probably left its parent galaxy, the energy from this eruption has now decreased. Astronomers speculate that the gas may have been expelled due to the power of the explosion, much like wine spills from a glass when it is shaken. Radio astronomers have not detected any additional activity, indicating that the eruption has finished. There may still be many unanswered questions on how the event altered this galaxy cluster. For instance, why do other smaller events of similar sort show 2 such locations, but this object only displays one area of radio emission? The solution requires additional research, but one theory is that the gas of the opposite pole of the eruption may have been thinner than its partner and dissipated more quickly than the remnant we see now. We might see more potent events like the one in the Ophiuchus with future instruments. We might now discover proof of even more explosive eruptions in the distant past as telescopes and other instruments explore the heavens in the upcoming years. However, this explosion is the most potent one we are aware of in the history of the universe, at least for the time being. There is a great deal that we do not know, but the point is not to get disheartened because this ignorance is a beautiful thing. It is what ultimately motivates research and what truly awes us about the universe. Even after Homo sapiens have loped around for hundreds of millions of years, the cosmos may still baffle our fidgety, curious minds, easily outpacing our vast imaginations. How fantastic! Alright, we reached the end of this video. Thank you for watching. If you liked it, give it a big thumbs up and share it with your friends. Drop your comments. That's a wrap. We'll see you in the next video.